Hi everyone and welcome to the Quaudio Sound Laboratory. Okay, it's also my kitchen, but there's a reason I brought you here, and that's because I want to demonstrate one of the cool things that I've done with this audio DSP technology. So the program, the code, the algorithm is running live on the Raspberry Pi, and I programmed it to perform three things. Well, in the first mode, it's just an omnidirectional microphone. In other words, it isn't doing any dereverberation. But watch this, I'm going to switch on Quaudio. There we go. So Quaudio is now switched on, and what it's doing is it's doing active beamforming. It's tracking me as I walk around the room, and so you can imagine me, if this was in like a conference table situation, for instance, you could have many people sitting around the room, and it would be immediately creating pencil beam microphones that would be picking up on those voices. At the moment, we've got a random efficiency of 7 dBs. So random efficiency is a measure of the ability of a microphone to suppress diffuse noise compared to the primary direction. In a cardioid microphone, for example, typically that you're going to get around about 4.5, 4.7 dBs. Already, this is giving you 7 dBs. Can we do any better? Damn right we can do better. Here we go. Okay, so another push of a button, I've really now upped the game, okay? We're now getting 12 dBs of random efficiency. Hopefully you can hear that effect, that my voice is now really starting to sound a lot drier. It's almost as if I'm using a microphone held straight up to my mouth, when the reality is the microphone is currently more than a meter away from my mouth, yet it still sounds as if it's really close. I've really suppressed that room effect. Just to remind you, I'm going to go back to the original omnidirectional mode. Boom, there we go. We're now in omnidirectional mode. And again, you can hear that annoying room effect, if you like, those echoes, reverberations coming off of the walls. And here we go. We're now in the first quad mode. Again, 7 dBs of random efficiency in this first mic, in this first mode, which, by the way, is going to work in both elevational mode, but also both in terms of azimuthal angle, but also in terms of elevational mode as well. So watch this. Quaudio is actively tracking me, and I can be turning the microphone around really quickly. The response time for Quaudio is less than 1 second. So if you watch this, we can trick Quaudio. So I'm going to talk to Quaudio from this angle, and it's going to think I'm coming from this direction. I'm going to be silent for a second, turn the microphone around, and pay attention as Quaudio finds me. And here we are here. Now, listen to that again, rewind the tape a little bit and have a listen to my voice. You would see that Quaudio missed the first fraction of a second, and that's because the beam was spinning round and finding where my voice was. But trust me, Quaudio is working very, very fast, and that's all completely programmable. You can have faster response times if you want. In this demonstration, I've programmed it to have a 1 second response time, but that's fast enough for sure for this demonstration. So again, here we are. We're now gone into, if you like, the quad plus mode, and so now we are getting 12 dBs of random efficiency. You can imagine putting this, for example, into a conference mic system, or having it sitting on your desktop next to your laptop, for instance, and to really clean up the acoustics and to suppress that room effect, if you like. You would put the Quaudio algorithm into your microphone array design. Again, this is what it sounds like when Quaudio is switched off. And this is us in the initial Quaudio mode with 7 dB suppression. So there we go. Thanks for tuning in, and keep an eye out. I've got tons of great demo videos coming your way to show you what amazing things we can do with Quaudio. For more information and to discuss incorporating Quaudio into your audio product, please contact me on the email address shown here.